We can also find absolute extrema from a graph of f prime. Let's say we have a little graph right here. But to be able to do this, though, we first have to be able to find the value of any value of f of x if we have a graph of f prime of x and an initial condition. So first, let's go ahead and refresh that. Remember, an initial condition is just something that we're told, like f of 2 equals 3, or something like that. So let's do an example. F prime of x is graphed at right. If f of 2 equals 3, which it should be 1, this right here should be A, find f of 5. So here's our little graph right here. The key thing to remember is the fundamental theorem of calculus. We know f of 2, we want to find f of 5. We can use the fundamental theorem of calculus to relate those. The integral from 2 to 5 of f prime of x dx is going to equal f of 5, which we want to know, minus f of 2, which we actually know. Remember, with the bounds, left on bottom, right on top. So 2 is on the left, so it goes on the bottom. 5 is on the right, it goes on the top. So now the thing is that we know that the integral from 2 to 5 is the signed area of f prime. So we can hop right over here and say, okay, from 2 to 5, what is this signed area right here? And this is a triangle, so it's -1 height times 1 over 2, or negative 0.5. And this is 2 by 2 divided by 2, or 2. So this is going to be negative 0.5 plus 2. F of 5 we want to know, and f of 2 we're told is 3. So if we add this up, this is 1.5. Add 3 to both sides. We can also do the same thing if we wanted to find, say, oops, this is part B, find f of -1. Other than that, the problem's the same. Well, we know the integral from -1 to 2, because we know f of 2, and we want to know f of -1, of f prime of x is f of 2, which we know, minus f of -1, which is what we want to know. And again, we know that the area from -1 to 2, right here, is going to give us this integral. And so what we have here, actually with this one, we can just count blocks. 1, 2, these are each a half, so that's 3, 3.5. F of 2, we're told is 3. F of negative 1 we want to know. So there's a minus sign there, so let's add f of negative 1 to both sides. Subtract 3.5. And there we go. So make sure that you're able to do that. Go back and practice on it if you need to. Let's move on to doing some practice problems. So, I believe this is problem 2. Find the coordinates so that's xy of the absolute maximum of f of x if f of 2 equals 3. F prime of x is graphed. So maximum and f of x goes with the increasing decreasing line. We have a graph of f prime, so let's go back to our graph mode. This is f prime of x, and now remember I'm doing my translations based on this. I've got f prime, that's going to be plus minus when f of x is increasing decreasing. So fill in the plus minus line from the graph. Oh, let's see. Looks like we stop at negative 5 and positive 5. So we've got positive up until negative 2, negative up until 2, and positive up until 5. So when we translate that, positive becomes increasing, negative becomes decreasing, positive becomes increasing. Possible absolute maxima, it could occur either right here at the relative maxima or right here. The little circles are the possible maxima. So to figure out which is actually it, let's see, that was negative 2, that was 2, negative 2. So if there are possible absolute maximum at x equals 2 and x equals 5, we want to compare them. So let's find f of negative 2. And remember we have this graph here. We know what f of 2 is. So just like we were doing earlier, we want to set up, using the first fundamental theorem of calculus, a little integral that will let us calculate that. So we know the integral from negative 2, that's the smaller number we want to know, to 2, which is a larger number, which is what we do know, of f prime of x dx. That's going to equal f of 2 minus f of negative 2. F of 2 we know is 3. We want to know f of negative 2. And now we need to find this area right here. So from negative 2 to 2, this is 1, 2, 3, 4 base times height divided by 2. Oh, that was positive 4 here, negative 2 here. But in any case, it is a negative signed area. It's under the x-axis, and it is negative 4. So this is coming down. Draw it really lightly in pencil. right there. So add f of negative 2 to both sides. Add 4 to both sides. F of negative 2 is 7. Now let's look at, so that was for f of negative 2. Now let's look at for f of 5. Well, from 2 to 5, this area, the base is 1, 2, 3 times the height is 2 divided by 3. Divided by 2. That would give us 3. So we know the area under the curve from 2 to 5 of f prime of x dx, that's going to equal f of 5 minus f of 2. We just found this area is 3. Again, that's coming from the graph. F of 5 we want to know. F of 2 is 3. So add 3 to both sides. F of 5 equals 6. We're looking for possible absolute maximum. This is bigger. F of x has an absolute maximum. At the point, because it's asking for the coordinates, the xy coordinates right here, negative 2 comma 7. Because f of negative 2 is greater than f of 5, and all other values are less than these. Our final problem is a check for understanding, so please copy this down, solve it on your own, and then restart the video when you're ready. It says to find the coordinates of the absolute minimum of f of x is if f of 0 equals 1. F prime of x is graphed right here. Pause the video now. Okay, f of x, absolute minimum, that's increasing, decreasing. So we've got a graph of f prime of x, so that translates to positive, negative. And let's see, it starts at 0, it ends at 6, starts at 0, ends at 6. And we can just fill in this f prime of x, positive, negative, directly. So it's positive until x equals 2, then it's negative until x equals 4, and then positive again. So translating to increasing, decreasing. It's right like that. Absolute minimum, so we're interested in this point right here and this point right here. Those are potential absolute minima. So let's start off with finding f of 0. Well, actually, f of 0 equals 1. That was pretty simple, given in the problem. Let's then go ahead and find f of 4. So we know f of 0, we want to find f of 4. So the integral from 0 to 4 of f prime of x dx is going to equal f of 4 minus f of 0. So from 0 to 4, we know that this area right here is 4. Count those little blocks, 2 times 2. We know that this area right here is going to be width of 2 times negative 3 divided by 2, so that's negative 3. And then we stop there. So the area here is 4 minus 3 equals f of 4, which we want to know, minus 0, which is 1. 4 minus 3 is 1. Add 1 to both sides. f of 4 equals 2. So this is larger. Oh, but we're looking for the absolute minimum, so we don't want the larger one. This is smaller. So that means f of x has an absolute minimum at the point 0, 1, because f of 0 is less than f of 4, and all other values are larger than these two.